This is Geometry Lesson 7-1. Today's date is Monday, March 30th, 2020. Our objective today is to find the distance between any 2 points on the coordinate plane. I'm trying to keep these notes as brief as possible. So I'm eventually going to show you the formula, but I want to show you where this formula down here comes from. If I have 2 points, point A has coordinates -3, 2, and coordinate B has coordinates 3, 4, how am I supposed to find this diagonal line, rather the length of the diagonal line between those 2 points? And the general idea behind all of these is you always want to be using a right triangle and use Pythagorean Theorem. So if that's my diagonal, I should be able to find 1 or 2 different right triangles. So the first triangle that I see is I can do a triangle that goes from this coordinate 3, 2 to A, and then I can do a point. I'm going to have to draw it off to the side and then move it over. There's the one right triangle I can see. I can also see another right triangle that goes up there, but I'm going to do the one that's on the bottom for now. This length down here is going to be, or to the right is 2, because it's a total distance of 2 squares, and then I can count 1, 2, 3, 4, 5, 6 squares for this bottom side. And now I'm using Pythagorean Theorem. So I have leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared is equal to c squared. Plug it in, as I just said, we're going to do 6 squared plus 2 squared, and that's going to be equal to this c squared. If I call this hypotenuse c. Alright, so from there, simplifying, 6 squared is 36, 2 squared is 4. That's still equal to c squared, and therefore c squared is equal to 36 plus 4, which is 40. I'm not done yet because I want to find c, not c squared, so just c. I'm going to have to square root both sides. So I'm going to square root the right hand side of the equal sign, square root the left hand side, and c is equal to the square root of 40. In Khan Academy, that's enough. You're done. But in my class, you should also know how to simplify this using a factor tree. This can be 4 and 10, or rather the square root of 4 times the square root of 10, and therefore that's equal to 2 square root of 10. I'm not going to assess you on that. I just wanted to remind you that this is not the final answer. You do have to do a factor tree and find a perfect square in that factor tree, but both of those answers are going to be considered correct for today. So you don't have to worry about that step in blue. So what is the formula and where does it come from? It comes from the Pythagorean Theorem, if I keep it very general. Remember, what was A? A was 6, and 6 is the total change in x between A and B. The x coordinate of A minus the x coordinate of B, and then just taking the absolute value of that. Sorry, that's Riley in the background. And then what was 2? 2 was the total change in y. So the formula looks like this. I have to take the square root at the very end. So there's the one that I like to use because it's simpler, and then there's the textbook answer. So here's Mr. Sindel's formula. You take the change in the x's, the x coordinates between the 2 points, and then you're going to square that. Look, this looks like 6 squared, and then I'm going to do plus that other thing squared, so plus the change in y quantity squared, and then I'm going to square root that at the very end, because I eventually add them together, and then I took the square root, and that was my answer, square root of 40. So that's the easier formula to memorize, but then there's also the textbook answer. So if I call this point 1 and this point 2, then I can say something like this. I can say the x coordinate of 1 minus the x coordinate of 2, that quantity squared, and then I can add that to the y coordinate of 1 minus the y coordinate of 2, and that quantity squared. All of this thing square rooted. But this gets so long and long and long that it becomes difficult, but these two are equivalent. These are the same. You can use whichever equation, whichever formula you'd like. Alright, so let's apply it. Go ahead and try doing example 1 on your own. Here's how you actually do it. Again, I'm trying to find the hypotenuse here. I'm always thinking of the hypotenuse. In terms of how Mr. Sindel does these problems, I don't memorize a formula. The formula is nice and it's useful, especially for example 3 on the back, where I just have numbers to plug in. I always do Pythagorean Theorem. I always think to myself, all right, what is the length of this leg what is the length of this leg, and I'll move that up, and then I use a formula on it. So I have a total distance between -4 and 5, which means I'm going 9 for this change in x, and total change in 3. Notice that I'm always labeling the sides of my triangles positive, even though I might have labeled one of them negative or both of them negative. I'm always saying positive because these are lengths. That's a distance. That's a distance. Distance is always positive. Okay, and now I'm going to do Pythagorean Theorem again. A squared plus b squared is equal to c squared, and I'm calling that my c. And you might be saying, wait, why aren't you just using the formula? This is the way that I solve them every single time. I don't go back to any old formula. If you want to do a shortcut, you can use a formula. This is going to be 3 squared plus 9 squared is equal to c squared. This is going to be 9 plus 81 is equal to c squared. This is going to be 90 is equal to c squared. And c is therefore equal to, if I take the square root of both sides, it's the square root of 90. This can be simplified. Again, this is your answer in Khan Academy. You choose this, you're done. But the square root of 90 is really the square root of 9 times the square root of 10. Square root of 10, and that's equal to 3 square root of 10, which is my final answer. But again, that's Khan Academy's final answer. Example number 2. Again, try it on your own, but here's how you solve it. So again, I'm always thinking of my right triangle. I have a line that goes right there, a line that goes right there, and voila, I have my right triangle. Let's actually make it a right triangle. And let's go ahead and find the length. So I have a length of 1, 2, 3, 4, 5. They'll always give you a grid for this type of question, so that's how you can count the squares. And this is a length of 3. And then again, I'm plugging into Pythagorean Theorem, which states a squared plus b squared is equal to c squared. When I'm plugging in, I get 5 squared plus 3 squared is equal to c squared. Again, reminding you that it doesn't matter the order in which you plug into the legs. And the other cool thing about this problem is, these types of problems in general, is they're always plugged into legs. You remember you might have plugged into c squared before. That's only if you know the length and you're trying to find one of the legs, but you never know the length because it's always asking you the length. So you're always plugging into the left hand side. This is 25 plus 9 is equal to c squared. Adding the left hand side of the equation, we get 34 is equal to c squared, and therefore if I square root both sides, c is equal to the square root of 34, and that is my final answer. I can't go any farther than that because this is 2 times 17, neither of which are perfect squares. So square root of 34 is the length of this blue line. And finally, example number 3, what is the distance between -3,5 and -6,1? This is one where it might be actually kind of useful to draw out the formula. I'm using the formula delta x squared plus delta y squared, and then that whole quantity square rooted. So first, what is the change in x? And then I'm going to square it. The change in x between -3 and -6. Again, it always goes x, then y for my coordinates. So how much have I changed between -3 and -6? If you can't see that in your head, I wanted to get rid of these circled values. So let me, I guess I'm going to have to delete all of them. That's weird. It's x comma y. You can always think of it as just subtracting. If you want to find the distance between anything, it's in anything, not even for just math class, it's just subtraction. So I would say -3 minus -5, and that turns into -3 plus 5. Since these are opposite signs, the answer here, why am I doing 5? It's a good question. Minus -6, sorry about that. And then I'm going to add, and -3 plus 6 is +3. Again, if you can just visualize how far is it between -3 and -6, maybe on a coordinate plane, I start here at -3 and then I'm going to go 1, 2, 3 to get to -6. That's how I visualize it in my head. I don't do any subtraction problem where I have to worry about negatives and positives. I just visualize it. Anyway, I've told you now that the change in x is 3, so I'm going to square that. Plus, now I need to find the change in y squared, and then eventually I'm going to square root all of that. So the change in y, this is the y coordinate, this is the y coordinate. How much distance is between -1 and 5? Well, the answer is 6. 6 squared. How do I know that? Because again, I'm thinking of a coordinate plane. If I start here at -1 and I have to go all the way up to a height of 5, I have to go up 1 to get to 0 and then up another 5. So up 1 and up 5 is 6. Again, if you don't like that, you can use a subtraction problem. I can say, what is 5 minus -1? And then again, double negatives means I'm going to make them both positive, and that's going to be 6, which is what I get up here. And I'm almost done. So 3 squared is 9, plus 6 squared is 36. I'm taking the square root of that still. And then adding these two together, 36 plus 9 is 45. 45. And I'm taking the square root of that. And that is the final answer for Khan Academy. But in my class, you should be able to know that 45 is the same thing as 9 times 5, or the square root of 9 times the square root of 5, which is therefore equal to 3 square root of 5. So I'll box my answer, maybe I'll circle Khan Academy's final answer. And now you know the 3 types of problems that you'll encounter on the homework tonight. Let me know if you have any questions. Again, my office hours are 12:30 to 1:30. I'll see you guys tomorrow.